Right, so
I think
it's
we're
almost
ready, right?
2:05. I think we can now start the official part of the webinar.
Okay. For the beginning, I would just like to break some ice with a few questions. So, as we mentioned, today's topic is floor plan extraction with automated line detection. This topic was chosen because a lot of people started working on floor plans, and the traditional way tends to be sort of, slow and cumbersome. So we
Yeah,
are
so
offering,
traditionally we would just use like a dista and just measure
yeah,
the distances and end up drawing sort of a floor plans, right?
and that can take up quite some time. So let's see how many of you are already 3Dsurvey users. Here's the first poll, the first question. You can start inputting your answers right away. As we see on the fly, there's quite some of you returning users. With every new version of 3Dsurvey, we add some more features, and I believe it's hard to be updated with all the new features all the time. So that's a good thing to watch a webinar for. So almost 70% of you already voted. If you've just joined us, don't hesitate and go straight for your answer. Okay, closing the polls. 1, 2, 3. And here are the results. So we got 2/3 of you who are already 3Dsurvey users, 1/4 not yet, and 8% of you thinking about it seriously. Thank you for your first answers. Let's continue with our second question. This one is a bit more on topic. So very simple. Are you already using a SLAM device? So that is a handheld SLAM scanner for acquiring scans of buildings and other objects.
Wow, here the answers are coming in very quickly.
Yeah. Okay.
74% of people have voted so far, 75.
Very good. And the ratio is
It's
quite
not
tight.
what I would expect initially. So
Okay, so now we know who we're talking to. Okay, last few seconds. Thank you for your votes. Here are the results. So 58% of you already have a SLAM device and are using it, and 42%.
So that is quite more than what I had initially expected before this webinar. So interesting. I see that this technology is progressing very quickly to the end customers. Very interesting.
Yeah. So you should be a bit more familiar with today's topic, since you already know what the device is getting to you. And now, today, you will learn how to use those results most efficiently. I have one more question for you, and then we will begin with the topic. So I mentioned today's topic is focusing mainly on the floor plans. So let's explore what the pain of traditional way of measuring floor plans was, in your opinion. So here you can choose more questions, but you can choose which one is the biggest pain for you. So Was it drawing a sketch on a field? Because you come to the object and then you need to, draw a sketch, put in every corner, and sometimes it's not a rectangle, so it's a bit difficult. Is it the biggest problem non-perpendicular rooms or walls? This can also be quite tricky to measure. Or maybe cluttered spaces with a lot of obstacles, so you can't really measure. Or maybe is the biggest problem insufficient measurements. So when you forget something, when you forgot to measure a distance to something that didn't seem important at first, but later in the office, you figured out that you really needed that information. So Vid, what would you choose?
Probably I would choose drawing a sketch, drawing the map of what I have measured, and then because I will used to do it with the Disto device, also writing all the numbers, making sure to get
Ah,
everything right. And then of course there's a problem if the measurements don't fit together. That's also a very big problem. So both
yeah,
non-perpendicular walls, and I think you have summed up the difficulties very well, Mattia, because I think 68% of people have voted by now. I think we
okay,
can check
should we
the
see the
results.
results? All
Yeah, let's
right.
do that.
The results look very interesting, very colorful. So, yeah,
So we can say all of these things are problematic. The biggest problem is insufficient measurements. You're forgetting to make a measurement.
yeah. So this one is actually the easiest solvable with use of SLAM device because it gives you so much information that you practically never need to return to the site and do a measurement again.
We will always be able to find some point on some elevation.
Yeah.
We still get problem of non-perpendicular room walls, but maybe now we can better decide which line to take from the measurements, right?
Yeah. Okay, everybody. Thanks for these questions. I mean, answers. They give us very nice insight. And now Vid will guide you through the presentation and show you some best practices and maybe some new approaches. So pay attention. Oh, one more thing before we go. This webinar is going to be recorded. It's recording right now and it will be available to watch again in the future. You'll get an email with the recording. And
Probably
now,
tomorrow, right?
yeah,
And I
with
think by now you can already see my screen, and the topic today is how to do floor plan extraction with automatic line detection and our X-ray views. So here I have a general outline of our presentation today. So usually I start by going into theory first and explain some theoretic backgrounds and how it works. Today I will do things a little bit differently. First, I will show a general workflow, how to extract plans, and then we will go into what's important in order to make a good floor plan. So first, we'll just quickly go through 3Dsurvey and make a very quick floor plan extraction. Then we will talk about point cloud normals and how they affect X-ray generation. We'll talk about parameters for the X-ray view calculation and how to set the threshold for the automatic layer detection. And then finally, we will look at some example projects. Okay, let's go now straight into 3Dsurvey. And here I have a small data set. Let me just set up my screen, move this away. Right, so here I have a point cloud of our office building. So the outside of this building was recorded with our DJI Mavic 3 drone in the January this year. And for the insights in this example, I have data from, in this case, what was a Matterport scanner. But the situation is pretty similar for any kind of scanner. So now this is what the workflow will be like. So the first step is we need to calculate X-ray views. Select here, calculate X-ray views, and press generate. We'll go into details later, what the options are. So the calculation will run for a few seconds. Usually it takes about half a minute. The processing time depends on the settings that we used and how many points are in point cloud. So what is happening? Like this, 3Dsurvey converts the point cloud into top, front, and side view. Now, so here you see the insides of our building office. So maybe we could say this one of the cluttered places, because you see that we have a lot of vertical objects in here. So here we see the cars, this is our entrance, these are the stairs leading into our office, and I want to extract a building plan here. So what I will do, I will create a layout. I will draw my layout area. So for this one, initial one, I'll just do it like something like so, not really paying attention to how I do it. Confirm. And now I get my slice. Already pretty good one. So now that I have my slice here, on the slice, we can disable the top, front, and right view, so to get the better view of the slice. And finally, we will click here and we will click on detect lines. Before we do that, I will go here to my CAD layer. I will create a new layer and we will call this one first example, just something. Make it the current one. I always like to do that when I create a new layer, because when I go now into detect lines, this is automatically the layer that will be selected. And now we will press detect, and already we have some lines here.
Wow, looking good.
Pretty good for just maybe not the best parameters, and just doing something, you know, off the top of my head. Now if I go back into CAD, these are now the lines that we have extracted. And if we go to data, save CAD as, we can then save those lines into a DXF file, and we can also save this view into a DXF or TIF or JPEG or any of those parameters, right? So that was just the basic workflow. I just wanted to clear this out first so that you know, that you understand what we are talking about a little bit. Now let's hide this one and let's go here to CAD, put it back on default layer and hide this first example. Right. Now I would like to go a little bit more into theory, how the X-ray calculation works. And I have a slide for that here, which will help me explain it a little bit. So go to slide number 2. Now we will be talking about what are point cloud point normals. So the X-ray algorithm, which we have here in 3Dsurvey, it's a special one. If it has information on point cloud normals, it will use them. So a point cloud normal is a vector perpendicular to a local point cloud surface. So I have here a picture and I will try to explain it. So here we have a sensor shown as a point in space. And let's say that this sensor has recorded these point cloud points. So if we take this point here in photogrammetry and also very often in LiDAR scanning, it helps us if we also know the local normal in this location. So we have an option to calculate this vector, which is perpendicular to the local plane. So this is the plane that best fits the nearest, for example, 10 or 20 points in the point cloud. Whenever we calculate a point cloud with photogrammetry from photos, we usually will also automatically always calculate these normal vectors, because these normal vectors, they help us a lot. If we know the first point cloud point is here, we have this normal vector, we can automatically assume that the second point, it might be here or it might be a little bit lower, something like that. And we are always using this kind of information. So when in 3Dsurvey we are calculating the X-ray image, the calculation goes like that. So an image is like a grid of values. And let's say that 4 points fall into this first cell here, the one that I'm marking here with my mouse. So if a point cloud will have normals, 3Dsurvey will create white color only if the points falling inside have normal vector which is close to parallel with this image. So that means the points which have normal looking perpendicular to the image, these will be ignored. The result is that when we create an X-ray view, so here we only get vertical walls. So we don't want to get, here you see we have a little bit of roof, because on the roof the local surface was at 45-degree angle. Here where you see the edges of these roof bricks, roof tiles, we get a little bit more color. And for example, for the car, we can get a nice backside bumper and front side bumper, but we don't see the roof like that. So first, the most important thing, if you want to use automatic line detection in 3Dsurvey, your point cloud needs to have normals. Now, how to check if a point cloud has normals? So here I have two sets of point clouds. So this is the first one. This point cloud has normals. This is the second one. This is without normals. So it turns out they look almost exactly the same with the normal settings. We will see difference if we turn on shading like so. In that case, point cloud with normals will usually have the bottom side display more dark, and the lighting of the point cloud will change based on how we turn the point cloud. So you see now this side is looking brighter now, and here it's looking slightly dark. If we go to this one, it looks the same no matter how we turn it. Might not be the simplest way to check for normals. There is even a simpler method. So if I right click on a point cloud without normals and I go down here, there will be an option calculate normals. So that means for each point in the point cloud, calculate the normal vector. On the other hand, if the point cloud already has point normals, when I right click on it, we get an option to remove the normals or to invert them. Invert them means turn them upside down. So for example, if the point was facing now up normal, you can make it rotate down. We added that function because it can be useful in some examples, but we are not going to that now. So right. So why is it so important to have normals? Because if I go into X-ray views, I have here example of X-rays. This is not right. Let's just recalculate. So we go to X-ray views, calculate new X-ray view, and let's see what we get if we calculate from point cloud without point normals. Press generate. Let's wait for those 30 seconds for the calculation to finish. So now 3Dsurvey is not using the normal information in X-ray calculation, and because of that, this is what we get. So where we have floors, we only get white color. So from this, it might be quite difficult to get a good floor plan. You can see that here, only here we see a wall. Only there where we have a wall, we see some roof through the X-ray. So this will not be useful. So let's just delete that. So
what can we
one more
do if we don't have normals?
easy. You click here on point cloud without normals and you press calculate normals. Press yes here, and then there are two parameters for the normal calculation. This one means for each normal calculation point, the 3Dsurvey will find 20 nearest points to the point of interest, and it will use them to calculate the local plane. And then there is this second parameter, simplified cloud relative size. If you only use point cloud for floor plan extraction and automatic line extraction, always set this parameter to 0 because that will speed up the calculation. So why this parameter matters? So what actually happens? So this is already super advanced. But actually, when we calculate this local plane, we get a normal vector. But it turns out we cannot, if we just have the points here, we cannot say if the normal vector is pointing up or down. So some normal vectors will point up and some will point down. And then that parameter is used to help us figure out, to find the closest point to each point, and then it just checks if this one is pointing up and this one is pointing down. It will take the second one and it will point it up. So just to get most of the normals pointing in the same direction. But for this algorithm, for the X-ray views, it does not matter if a normal points up or down. It will be used in any case. Because of that, if we go back to these parameters right here, click one more time point cloud without normals. Yes, this should be default parameters for calculation of point cloud normals. Okay, copy, it should be in here like that. Right, so these are point cloud normals, and the only thing to get from this, always use point cloud normals. So even better option than calculating point cloud normals in 3Dsurvey is if you have an option, if your SLAM device supports it, export your point cloud with the normals included. Because on the other hand, when SLAM is doing the mapping, because it knows where the points are recorded from, the normal should always be pointed towards SLAM. So the SLAM will be better able to calculate those normals, and if you have them, then the mesh calculation and these kind of algorithms will work even faster. So because of that, if you have an option to export those normals from your SLAM raw data processing software, do that at that step, right? So this was the first theoretic topic. Now for the second one. So when I was calculating the X-ray views, you saw that there we had some parameters to set. So there were two main parameters, target resolution and color transparency. So if we go here, cancel here, point cloud with normals, we will just remove it for now. I mean the other one, this one without normals, because we'll not be using it anymore. Tend to make this mistake very often actually. Here we have we have some parameters. So the first one is target resolution. That means pixel resolution for the generated X-ray view. So these parameters, they will actually depend a bit on your SLAM model. So different SLAM models, even different models from the same manufacturer, they can have different resolutions. The resolution also depends on how far away from the object you are when you are mapping it. Also, the point cloud noise will depend a little bit on the sensor and these kind of things. So, but in our testing, we kind of saw that usually it works best if you use target resolution between 1 or 2 centimeters. So for now, initially, before we get a lot more information about different SLAMs and before we get to test a lot of different SLAM models, these are our rough instructions for setting parameters. So if our building is if we have a small building sized project, I tend to set a resolution of about 1 centimeter. If our building is very big, on the other hand, or if we have a project with multiple buildings, then we set resolution to 2 centimeters. And it seems to work on most cases. And then there is the second parameter. This one is called color transparency. So what does color transparency mean? So color transparency tells us how many points need to fall within a certain cell in order for that cell to become completely white. So if we set that one to 90%, that means 10 perpendicular points need to fall in order to get white color there. So here I usually default setting is 70%, but if you have higher end scanner, you can set it to 80 or 90%. So lately I've been testing mostly 80 or 90%, but that just tells us how the final X-ray will be looking.
So basically you could say the better the scanner, the higher the number for this parameter.
The second thing is you also will need to test it out. Start with 80 and 90% and see how it goes. Let's go back here. So for this one, point cloud width normals, this one will set to 1 centimeter. And for the first test, we will set it to 80%. Finally, there is also transparent background. This one just tells us if the background of the X-ray is black or transparent, which basically means it does not have color. Let's press generate and wait again for those 30 seconds and see what we get now. So here I have an X-ray view. This one has 1 centimeter resolution, and here transparency was set to 80. And I think on this one up here, it was set to 90, so it's pretty similar. Test out what works better and see how it is.
So what if you wanted to make a change? Do you have to do it all again?
So yeah, of course. Let's not forget about that. We can always come here to our top view and select here recalculate, and then we can change our parameters here. And we can, for example, change this one to lower value and see how it affects our X-ray view.
So you can save some time not to recalculate everything.
But it's not necessary to do that in this step here, because here we now get our initial views. So after you get your views, and it will help you if you try to rotate this view a little bit. You see, because now my building is rotated at about 30 degrees here. So once you see that you can see through the roof and through the floors of your building, the next step will be, if we go here to the third slide, it's called model rotation. So we go here into X-ray views, and here we will use this first tool here, align model it is called. Let's click on that one. A window pops up here to let us know that we are working on something, and we will come in here and we will select our view rotation just like that by clicking. And now I will set my new coordinate axis here. So that means we will now rotate this image by 31.5 degrees and press confirm.
So you started in a corner and you aligned it with the walls.
Yeah, you try to find a well-defined wall and you just draw the line along it. It will also draw a perpendicular line. You want the entire model to align nicely with those two perpendicular walls. After we do that, then here in our side views, now we also see through the side wall of the building. So this is view through the front wall. And here we have the view through the right wall. Right. Now we can start to prepare for our line extraction. But in here, you see we have way too many lines. So what will we do in the next step? We will now define our layout. So we go here to this second icon and we create calculate new layout section. If we draw the layout on front or right view, we get a top-down view. If we draw it here, we get a cross-section. Right. I'll create a new one in here. You start drawing from the left to right, and then you always need to move it down like that. So we will limit it vertically. So for example, so here lately I've been playing around a lot with it. So the best way to set it, you just set it so that the so that here you get approximately 0.5 meter of elevation. So here we'll set again. So we have our snapping plane is here at 308.12. Let's put it down to 307.62, so that our layout here is 0.5 meter thick. And now when I move it up and down, you see that it's remaining at 0.5 meter.
Okay.
So this is our office building. It is a bit cluttered. In cluttered spaces, it works best if you take the layout at the top of the room, because here at the bottom we have many working desks and closets and these kind of things. Again, here we could change the parameters. For now, we will leave it how it is. Press confirm, and now we just get this view here.
So with this, you just filtered out everything else that was not in the yellow rectangle.
Yeah. So we just took now the points inside of the yellow definition. If I go here into properties, it shows me again where we were calculating from. And press close here. Temporarily turn these layers off. And then we get our X-ray view. So now, because this pixel size is 1 centimeter thick, you will tend to need to zoom in to best see the walls. So here, the goal is simply to create this layout so that our wall will be approximately 1 pixel thick. And but you know, the algorithm, it also works if the walls are thicker. So here it will be 2 pixels because, you know, the walls were not perfectly straight, or maybe the scanner was not accurate enough. Any of those, not a problem. Here we actually missed a room. Here we have something on the wall where we got some artifact. Right, this is what we have now. And if we are not happy with the parameters, we can go in here, press now recalculate, And now maybe in this example, I can go here and I can increase color transparency. Let's try to increase it high to 95%. So now these walls will be less strong white color. Press confirm.
And what if you wanted a more thicker walls?
If you want them to show up more thick, you would go simply in here, again recalculate and change, well, you would change this to 2 centimeters. Or if your walls in your example, like mine here, they are not displaying well enough, what you can do, you can increase the height of this subject. So for example, we can change this one to 3. So we are at top, so we will decrease this one to here, and here we will put 5.9. So now our slice will be 1 meter thick. Press confirm. Oh, let's just do like that. Create new. These parameters we will leave the same. And now we will make a copy and we can make a comparison here. And then you can try to do the line detection on both of them. Let me try to find the exact same corner. One here and down here. It's this one up here.
Yeah.
So you see here where I increase the height to double, then this line gets a lot stronger.
Because you got more of the wall in your interval. Mm-hmm. And which one will now perform better? The lower one?
I would say this one, because what you want to get, you don't want to get too many lines, basically. Okay. It takes more times to prune lines that you don't want than to, get the then creating new lines. So I think the top one should work better.
Okay.
Right. Let's go back here. So we covered properties and calculate. And now the final thing, let's go to CID, create new layer, second example, make it current one, X reviews. We can try on this one. So this, so do we get, oh, well, no, we're on the wrong one here, wanted to go here. Right click, press detect lines. When we press detect lines, a quick calculation is run. Software automatically calculates the best threshold to use. What is threshold? Threshold tells the software how wide a line should be for it to be considered. So here you see that we have some lines, something that's not very well visible. So this will probably, usually this will be some sort of noise or something like that. So when you press detect lines, software automatically calculates. It calculates that 70%, by default, it takes here threshold so that it will use 70% of the whitest pixels. Just set it up like so, press detect. If you don't get enough lines or if your lines are too short, you can delete them, come back in here, select detect lines again, and this time just decrease this number by about 10%. So in that case, I would put in 190 and press detect again, and then it would use more points. I won't go into details what the calculation does in the background because it's a bit complicated, but it works with standard deviations and stuff like that.
But basically, right, the threshold was maybe too high, so you need to decrease it to get more lines.
Exactly. Thank you. Okay. Press cancel here and disable this one. Okay. Go back to
now our... you've got that into CAD tab, right?
Yes. So now let's check. We have about a few more minutes. Let's check some sample projects, what I did after some processing here on these datasets. So first we will continue with this sample project of our office building. And then we'll also check some data from some scanners that we got sent in, and we will talk a little bit more about those. Okay, let's not waste too much time. Go back to 3Dsurvey, and we were here. Okay, so here you see that I have, for this office building, I have here created some special layers. So let's go back to our CAD, disable that. Let's go first to our ground floor maybe. And here I have our ground floor extracted. Let's go to our X-ray views, and I also named the X-ray view ground floor. And this is what we have. So here we have our ground floor, and it worked quite nicely. So we have a forgotten room here. Here was, so then here, you know, sometimes you will get small gaps in the views, in the walls. This is because hue transform is used to calculate those lines, and sometimes it will remove some. It will not connect all the lines the way it should. So in the next
the main
update,
question, can we edit those lines?
yeah, we do. But actually in the next update, there will be a better option. You will be just able to select those lines and say convert to a single polyline, and it will find automatic line. You will also get, we have a lot of here on the development list, how to further improve this. You will get an option to select the first one, second one, and then calculate the best intersection here based on the extending the lines and auto trimming them. But you also get a simple option. You can just select a line on the point cloud, just select a vertex like that, and just move it here. So here you get point snapping. So here I have enabled snapping on points and points or on the lines. You can just do that, this and that. I wasn't careful enough, like that. And now I fix this too. And you can go around and fix everything like that, and you will end up with a nicely defined floor plan. For the second example, I took the same building, and let's go here to properties. We created a cross section here across the middle of our building. Disable the top view, and on this one we also used the automatic line detection, and we made it, for example, orange color. So actually, whenever you detect lines on X-rays, the lines will be by default green. If you want them to display like that, orange, like, you know, to display different ones differently, let's do like this, select similar on same layer. You need to go in here and change color to by layer, because by default it will be set to custom and green. We did it like that so that when you create lines, so that you would not create white lines which would then be invisible on X-ray with white walls. Because of that, by default lines are green, but you can simply change them. Okay, let's go back in here. So here we see our side view. Most of the things came out pretty nicely. What we can show here, I'll just to make it better, I'll just disable the ground floor, go back in here. So here we have some lines. We can see if we go into drawing. So let's say that I want to draw, but also not forget. So cross sections should be visible and active like that. In here, I can go and now I'm snapping on this wall. Actually, I want this line to be straight. I can just press F8 or here object UCS, but a lot better, you just press F8 and the line jumps like that. And now I made, you know, you see, straight lines exactly to the wall like that.
Perfect.
Second thing, up here, I can make straight drawing to here. Then come here and let's do something with that. Now we'll just come in here and edit those two vertices. Disable the F8 to again disable this. And you see now it's snapping here. And now we will just move this one I have to press escape to disable the draw mode and move it and snap on this one. And now our side view of our office building is almost complete. We could maybe make it even a little bit nicer. Sometimes you will get this kind of thing. So this is the point, this is the lower end of our building, which looks like that.
A bit difficult to vectorize.
A bit difficult, yeah, to draw with straight lines. Let's say like that. Okay. And we have here also our basement and first floor and ground floor. And if we go to X-ray views, and now disable the section, enable the top. So here we now have the views together. If we go to ground floor, this is our ground floor. And here we see a bit of a section view and our basement and our first floor. And you get the idea. Maybe you will need to edit those lines a little bit, but it should save us a lot of time and energy.
Maybe we forgot to mention, you can also ask your questions in the question box. And while we was showing this example, we got one, and it's, can you do one example on any exterior building wall? I think this was partially covered. So I think Nicola is talking about a facade. So maybe windows and
well, we
doors.
could try to see what we get from that. Let's see what kind of examples we have here additionally.
Okay. Let's go through the examples, and we can also still return to that one if it's not covered.
So probably with this one, it will be hard to show that, right? So the first example we were showing, this one was photogrammetry plus Matterport. Now this second one, let's disable the bounding box. This one was created with StoneX X70. Let's enable back the bounding box.
It looks enormous.
Yeah, it's a lot bigger. And here are our automatically detected lines. So you know this trick, right? If you enable the bounding box, you make the bounding box thin like so. Okay. Then you right click on it, press Control on your keyboard, move it up down, and you just move the whole bounding box up down. And it's a great tool to make the cross sections like that. And we can see that we did a pretty good job of extracting those walls that we had well defined in here. So you would, in this case, you would just have to go in here and draw these short edges, because for now our line detection algorithm, it has predefined parameters. One of those parameters is at the shortest edges that we detect are 30 pixels long. So if we have centimeter, that means up to 30 centimeters. So the walls will need to be 30 centimeters or thicker in order to get those side views. Otherwise, you have to draw them up manually. And here we have the floor 2 and floor. And let's go now to the X-ray views. So these are all the views together. And if you go to floor 1, floor 2, you see that it got those walls pretty nicely and the ground floor. We just have to do a bit of fixing up in here, right? Just to not run up too late. Then I have this example. This is the newest one. This one is for X200 Go. So I'm not sure if this one is sorted already. Here we did automatic line detection on the whole layout, and I did a pretty good job extracting all the lines. I did forget to mention, but our line extraction algorithm, it usually tries to create points and vertices so that you get always snapping automatically done. So you see it so that the vertex here is directly on the here on our line here the perpendicular line. Looks pretty good for automatic line detection. And finally, final data set called the Galleria. So this one again, so this is a painting gallery that was recorded with this SLAM. So it actually turns out if you have a gallery like a place, it will have very little clutter. So in this example, you don't really need to worry so much about creating sections. You can just create a top view, and in this case, you will also get line detection to work nicely on the top views. But this works well if you are doing floor plans for some big store where it will be cleared out for scanning. In that case, it can save you a lot of time because it even works greatly on this kind of clear examples. Because if we go back into point cloud, we go into bounding box mode, go like that.
So you do this by holding down Control and right click.
So you see not a lot of clutter along the walls. Then also on the top view, you can get a pretty good result. See, so this is an actual gallery. A little bit of double sides because the paintings they can be slightly outside or something like that. Right, now the question was, can we do it on the walls? Well, not sure if it's intended for that purpose because I don't have a good example here because most of these they were recorded outside. If I go here and try to see what we have on the outside, for example.
You could try on the office building entrance, I think.
We can try there. So here I'm not expecting such good results because this one was done with photogrammetry. So this automatic floor detection, it works a lot better with SLAM point clouds. Let's go here. Let's create a cross section like that. Move this one away. Move this one here, maybe up to here. How this is displaying on those. Let's move it down. We don't need it to be so high. Up to
with
here.
This, you also limit the extent of your image when you save it.
This is what I am doing now. I'm just limiting my bounding box. Actually, this will be perfectly fine. And here we see well how far in and deep we are going. Let's press confirm and see what we get. So this is now our facade view. Here we have some columns on the facade. Okay, let's go create a new layer. Now this layer will just be called 1. Make it active, X-ray views.
It has a bit more noise than the
definitely
compared to the laser scanners.
Definitely. So if we go in here, so we see here, so this was just a drone flight. Pictures were recorded from quite high, so these edges are not that sharp. So we'll go here to detect lines. Now I will just, off the top of my head, I will decrease the threshold parameters by 10%, press detect. And this is what we get. We got something.
Not so bad.
Okay, the stairs, we're not getting them, because they are too short. Go to point cloud, both go to CID view, and we need to now disable some other layers. Maybe we could start working with that. Of course, with the with the very dense laser scan, I would expect this to be even a little bit better.
Yeah, but it's still a good result for this sort of photo, for this point cloud.
Yeah. Okay, and now I think we are getting to our favorite and also to the last slide, the questions and answers session.
Okay,
And I think,
we sort of started digging into this one a bit already. So if you still got questions, please set them now. There's a question box somewhere on the right of your screen, and we'll get to you.
so how we do, will you be reading out the questions today, Mattia?
Yeah, I can go through them and you can answer. So
Perfect.
I did already some of the basic ones. As we said, there's going to be a recording of this webinar, so you don't have to worry about this. Okay, let's just go. Is it possible to generate a mesh out of a point cloud? I think
Yes,
this is a
of course.
question about SLAM point cloud.
Yes, it is possible, but make sure that the point cloud has normals. So like we said in the beginning, this will work best if you can export the point cloud with normals, because the current algorithm that we have in 3Dsurvey now, when we calculate full 3D mesh, the point normals are taken into account. With photogrammetry, those point normals are always 100% sure. In theory, this point cloud normal calculation, it should work perfectly. The only problem becomes when we get to the edges. I mean to the perpendicular edges. Let's say I want to go to paint. Just
Advanced
very
tools.
quick explanation. How can I create some nice points in here? I'll just create stars like that. I forgot how to use. They change it all the time. Okay, let's say we have some points here and we have an edge going like that and then like that. So what 3Dsurvey does, it calculates those point normals, and it will calculate a point normal here. It will go into this direction. Or you want this to be how thick? I'll just leave it like that. Second one is here. This one is here. This one here, it will already take this point into account, and it will look a little bit more in this direction, like so. This one here might be up, so like that. This one here, maybe it will point this side. When it will come here, it will point that side. In theory, it should work, but in practice, these points, they also have some noise, and sometimes it might happen that this point here, the normal might be calculated like that. The angle between here will be more than 90 degrees, and then it will be turned like that. And in the end, because of that, you will get a point cloud here with normal facing like that, here in this direction. If your point cloud does not yet have normals, you might not get the result you want. We are actually solving this by changing how mesh calculation works. And our plan is now to have an update to have that solved with the next update. So if possible, make sure to export from your LiDAR processing software point cloud with normals. If you don't, our new mesh calculation will depend less on the normals. It will create nicer meshes anyway. So it will be also possible to create meshes from those SLAM point clouds effortlessly.
So short answer is yes. So next question is from Christoph. Sometimes I had a problem calculating the X-ray view. I think I only got an orthophoto and no views.
I
think
so
I know what.
yeah, so now we have two things. You have X-ray views. So these ones are limited to having the scan module. On the other hand, if you go here to point cloud and create X-ray here, as a result, you will get X-ray view, but it will be saved as an orthophoto. I can show you a little small trick. So for example, before you decide to invest into SLAM module, you can always do it like that. Set it up like so. Okay, we're happy. Select all the points. Delete other and calculate X-ray now. Let's set it the way we had it before. And you get a similar view even if you don't have the module yet.
Wow,
you can try with this one to start. Afterwards, if you think you need the side views as well, you can get the scan module to go.
And the scan module also brings you other things. You can also do orthophoto from
calculation.
Yeah, and you can also do orthophoto from point cloud. And if you're using a device that gives you spherical images, also you can view them only in scan module. So it has some advantages.
The manual registration and automatic registration, so it does have a lot of value, we think.
Yeah.
Right.
Okay, so that was the one for Christoph. And so far, the last question here is from Micho. Is it possible and how to obtain vectors of facade views recorded on historical facades that have many very small differences in dimension, protrusions, profiling, and architectural plastic, like the building you have on YouTube as an example? I think that building is our National Library. At least the description fits.
Okay. So, yeah, of course, it is possible to make it. We drew that one up a few years ago already, I think. And back then, how we went about it, we recorded it with the drone. So for that one, we used the drone and we did facade mapping. And maybe for this application, the best approach would be this. Go to our website and under webinars, there are two webinars on cultural heritage documentation and facade mapping. Maybe just search like that. You don't even need to go, just search facade mapping of Ljubljana Center, mapping buildings facades for 3D representation. This one is the one that might be interesting for you. And custom plane orthophoto and extracting window dimensions. Probably you're talking about this.
Yeah, it was this one, mapping building facades for 3D representation.
Yeah, so here it is explained how custom plane was created, how the drawings were made. When was this one done? This one was recorded with Mavic 2 mini drone. So
it's, I think, 4 years ago.
Been a few years. It's been a few years. Oh, so today this would probably be a lot faster because I would draw it like that in 3D. Definitely we would be using now the new tools in version 3.1. You would define your plane. So like that, you would draw your plane, confirm the plane here with the button or with right click. Then you would go in here. So unfortunately here I now don't have original images. So, but with the images, if drawing here, now drawing this window, it's a piece of cake because now all the lines that I create are automatically on this line. So this was now just a window, but it was not done the best way. So actually how this should be done is just press object UCS, we press F8, just like in AutoCAD. Now I'm drawing a straight line, going straight up in this direction, and then we just go do like that, and done.
Yeah, and as you mentioned, you could use drawing on images if you had the original images loaded in.
Yeah, so I would say for this kind of application, I think this is still the best way to go about it.
Okay, we have another question from Philip. Would it be possible to import, export X-rays in and out of 3Dsurvey, saving them as pictures or adding from other software?
Yeah, well, adding from other software is not yet supported, but if you go here and save this section, just right-click on it, save as. Maybe the best way to do it, you just save it directly into the DXF. Like that, I'll just create here a new folder.
Or if you need just an image, you can still
Export.
save it just as an image.
Example. In here we will put it, section DXF. And you get here the positioning, and you get the image itself. Of course, you can also save it like this, save as, and we'll just put it into. So you see now here these images, they have transparency as background, so it will be best to put them into PNG or TIF. So export TIF .tif it will be called. Now the georeferencing data format, we will put it into world file, so that means a second file will be created. Like that, save. And you have the image here.
Okay.
Like that. So you see, so here we see the image, we see the black pixels, but what was here displayed in dark gray, here it's viewed as transparent.
Yeah, this viewer doesn't have the best background color. But in AutoCAD, for example, it would look better.
But of course, you know, export TIF2, we get, if you put it into JPEG, the background will become white. So you probably would not want that either. Make it TIF2. We can select, actually, no, here we can't do that, yeah. No, in this case, the background will be always, it will always be transparent. Actually, you would need to come in here, press recalculate, and select here not transparent background. And now you see now the background is black, and if we save it now as a JPEG,
you can select the background color.
And now also the background is black, and it also displays nicely in images in the viewers where the background is by default transparent.
Okay, we have time for just a question or two more. Another theoretical one. So could you explain again what happens when you change the color transparency as a parameter? So this one is quite important. Might as well do it again.
So the color transparency parameter, it tells us how many point cloud points we need to fit into this cell in order for this cell to become completely white. In computer programming, a cell is white when it has a value of 255. You don't need to know that because the threshold is set automatically, but it will do like that. It will take a point which falls in here, and let's say that the point is like that it's completely transparent. That means it will add 25 to the whiteness of these pixels. After 10 points like that, perpendicular, I mean that line in the and in this plane, After 10 fall in, if it's set to 90%, the color of this pixel will be completely white. So for example, it then all depends, how you combine these parameters together. So if you set a very high transparency parameter, so for example to 99%, then the opacity, that's 1 minus transparency, then that's 1%. That means that 100 points will need to fall into that point in order for it to be white. We can try it, for example, to play around here. We can go to X-ray views, create new X-ray views. We'll just use all, put that one the way we have it, 1, 99 here, press generate.
So basically, a higher number of transparency means more
Less
of
white.
black.
Yeah.
Less white and more of a black background,
So we
or
were talking
empty.
what to add transparency or opacity. So we thought that transparency might be more familiar to most people. So, because of that, we added this one. So you
So
set
maybe if you
transparency and, just go back to this presentation, go back here and start out by testing out these two values and see what works.
maybe if you
So
quickly recalculate this one and use a very low number, we could see
we can quickly create a new one. And now we will set it, we'll leave it on 70 and 1. So 70 is pretty low for this kind of data.
So normally you wouldn't even go lower than 70.
Yeah, I think not. Because 70, that means if 3 points fall in. And usually with scanners, you will have resolution of about, let's say maybe 2 centimeters, something like that. Okay, now let's do it like this. And do it like that. So here you see this is with 90% transparency. This is the image we get. And this is with 70.
I don't think you, yeah.
Sorry, like that. This is with 70. See here, even the stairs came out very strong. And with 99, the stairs are almost not visible.
Mm-hmm.
The stairs are, how tall they are? They are 12 centimeters tall, right? In here, only a few pixels fell, because of that, then they are very transparent here. With 70, they become very strong.
Okay, I think that's pretty clear now.
I hope it is. Maybe just one quick test. You see how we got this? Now we have the whole image in one point cloud. You can try to see which walls will fall out, just for fun. Create a new layer here. Okay, it will be called like that. Detect lines. Now the threshold was calculated lower because most walls have less strong color. Press detect.
Yeah, the input was filtered before.
Yeah, and this is what we get. But it might look good at first, but then you need, before you will need to delete a lot of lines if you want to give this to someone. So because of that, we went through the whole workflow, how you go, the whole workflow, align, select the layout you're working on and everything. Because probably here now you have some line here at the basement floor, some from the second floor, some from the painting on the wall, and you get a lot of parallel lines. Finally, we did not get those edges. You can come in here, detect lines, make this one something very small. Let's put it into 70. Not something on the top of my head. Now you get a lot of lines. So
yeah, not so useful.
Not so useful. Yes.
Default, it's quite good, right?
Yeah. Just
okay. Yeah. And this was all for this webinar. We ran out of questions. I'd just like to say, if you want more information on this sort of stuff, we have a scan module site page on our web page. Go there, see if you'll find many resources there, data. We also have a few tutorials, and as I said before, the recording will be available in short, probably tomorrow, and yeah, you'll get it on your email.
So thank you guys for attending this webinar. It was a pleasure hosting it for you. Thank you for coming in such high number. And be sure to catch us on the next one. Until then, bye-bye.
Bye bye.